So we were looking at the methods of work transport, right? Work part transport in automated flow lines, right? We discussed that automated flow lines, how those workstations, those dedicated workstations are able to achieve mass production, and because they require this automated work handling, so you require the, this work handling devices, and there are different methods if you want to classify them as generally we have these three classifications. So a transfer mechanism uh, of the automated flow line must not only move the partially completed work parts or assemblies between the adjacent stations, right, as you were saying, it must also orient the look and locate the parts in the correct position for processing at each station. So it has to move also, right, and be able to orient and locate also, because we have seen that example in that video of that press feeding system, right, in the last class that we saw before mid, that that press feeding system, you have that sheet metal forming. So that sheet has to be properly oriented, right, and located so that the die can press it. So it is also the responsibility of this transfer mechanism, that it orients it and locates it at the exact position to the workstation. Okay, so either it for processing or assembly or inspection, okay, depends on the type of workstation. But the primary responsibility is to not just move but also orient and locate. So the general methods of transporting workpieces on flow lines can be classified into the following three categories. So we can classify them as three categories: that continuous transfer, intermittent or synchronous transfer, and asynchronous or power and free transfer. So three classifications we can make. So we'll see why they are classifying it, and also uh, factors for selecting which type of transport system should we use for a particular process, right, for a particular uh, processing operation, or for a particular product. Let's say that we want to make a product, what type of system should we choose? So different factors we have, whether the type of operation to be performed. What is the type of operation? Is it manufacturing? Is it inspection? Okay, is it like all the stations are doing inspection only, right, of different physical features? Maybe it could be some machines are that some machines are only inspecting the dimensions. Okay, let's say the next machine next to it is inspecting maybe the welding. Okay, how is the weld quality? The next could be inspecting the paint quality. Okay, machine vision, etc. All of these technologies you have. So just a minute. Okay, so uh, one major factor is your type of operation to be performed. Okay, what is the type of operation? That will have a major impact on whether you want to use your continuous transfer type of system, or intermittent, or synchronous, or asynchronous. Okay, so number of stations on the line, how many stations do you want to place? Weight and size of the work parts, even that matters, because you see in continuous transfer we have this problem that you have to continuously move it, it cannot stop. So if for example you are using it for a product like beverage, okay, that your cool drinks, etc., so it will be filled while they are moving. Okay, so in that kind of situation, if the same kind of continuous transfer is used for bulky products, then you have to take into account the, what do you call, inertia also, right? So size is also one, weight and size of the work parts also matters while selecting that. Whether manual stations are included on the line, even this matters, because if you are placing manual stations, then you have to consider that some, there will be some delays, right? Your machines are programmed to do it as per the exact time. Like for example, if you have set the cycle time to be 8 seconds for a particular workstation, then it will do it in 8 seconds, right? But the human worker may take a second or more. Okay, so that you have to include. And if the manual station, if the manual worker doesn't do its required duty, okay, because of miscellaneous reasons, then there'll be a problem on the whole line, right? So manual stations, if they are included, then that also has to be considered, because we do include manual workstations, right? We saw in the, what do you call, earlier classes, that manual stations can be incorporated also in the automated flow lines as and when required, because of either the uh, process that you're trying to perform, the operation that is being performed cannot be handled by an automated machine. Okay, it is either uneconomical or inflexible. Okay, I mean, not so, what do you call, justifiable for an automated machine. So in that case, you'll use manual station and a manual worker will be placed like that. So whether is that included, you have to ask that. And production rate requirements depends on the rate of production you're looking for. And balancing the various process times on the line also, this is one important concept in this category, that you have this, what is called, line balancing. So we'll try to adjust the different times on the machine. You'll try to what do you call, come up with the processing times, and see whether the storage system that you are keeping, buffer storage, what I told you, right, between any two stations, you will have a buffer storage. So is that able, is that enough, or do I have to increase the buffer storage capacity? Because machines, they require maintenance, there are delays, okay, because of any other reason. So if one workstation is down, that should not affect the other workstations. So there is a terminology in machines called starving. Okay, that you call a machine is starving because it is not being fed the work parts, it is idle basically. Or if it is, if there is a more what do you call, if there are more work parts waiting for this machine to be processed, then that is also another disadvantage, right? That you have this pile up of work pieces. So that is what line balancing considers. So even that has to be taken into account. So those are your factors. Clear so far, right? No doubts. Okay, so yes, for the three types. Okay, now we'll see what are the three types. So you'll understand why those factors are important. Okay, to be considered. So in the continuous transfer system, you have the work parts moved continuously at constant speed. So the speed is constant and the work parts are moved continuously. Requires the workheads to move during processing in order to maintain continuous registration with the work part, right? Even the workheads have to move. So you see, or not even, not just the work pieces are moving, the workheads also has to move, right, to be able to perform that process. So you try to imagine this, I mean, to a specific example of the beverage bottle. Okay, beverage filling. Right, have written, right, beverage bottling operations, packaging. So they'll move, right? That nozzle which is filling the bottle will also move with the bottle. So difficult to use this type of system on a machining transfer line because of inertia problems due to size and weight of the workheads. I told you, right? Even the workheads size and weight, inertia you have to consider, not just the workpieces. The workheads also carry some weight, isn't it? So you cannot implement this kind of system. It's difficult to implement this kind of system on a machining transfer line. Okay, wherein specifically you are looking at manufacturing, right? So because of inertia problems, so cases where continuous transfer would be very practical includes your beverage bottling operations, your packaging also, uh, manual assembly operations where the human operator can move with a moving flow line. So that is also one place in the industry, like the human operator does the manual assembly also, and relatively simple automatic assembly tasks also. So if it's a simple assembly task, then it can be done while it is moving. Relatively easy to design and fabricate, and can achieve a high rate of production. So those are very easy to design and fabricate when compared to the other methods of work part transport. Okay, we'll see a video regarding that, but first let's discuss the three categories of it. Intermittent transfer: workpieces are transported with an intermittent or discontinuous motion. So intermittent, as the name suggests, you have a break in between, right? Discontinuous motion, as opposed to continuous, you have a break here. Workstations are fixed in position, and the parts are moved between stations and then registered at the proper locations for processing. So the workstations are fixed and the parts are moved between these stations, okay, as we normally imagine it to be, right? And then registered at the proper locations for processing. So as I told you, that automated material handling is responsible for properly locating that work part for processing of it. And all work parts are transported at the same time, and for this reason the term synchronous transfer system is also used to describe this method of work part transport. So because they are transported at the same time, right, the work handling devices, I mean that work part transport system is so integrated that it will move, right? Let's say for example after 4 seconds it moves, okay, between there are workstations, this work part transport is responsible for moving these work parts to the workstations, right? So all work parts are transported at the same time. So all of them, you see, you imagine that all those machines have to have the same processing time, isn't it? For your work part transport system to transfer the work parts, right? These are your work parts, okay? So they are coming like this. So once the process is performed here, then it will go to the next machine, right? So they are as we saw in that press feeding example, uh, all those machines were trying to do a specialized function, right? One was achieving some particular shape on the sheet metal, right? One was trying to punch a hole, other was trying to form it, okay, bend it, etc. And finally inspection also to check the thickness. And so all those operations while they were doing, if you have this processing times of all those as same, then you can have what do you call, a continuous type of transfer, right? That Otherwise what will happen if you have different processing times, then you have to have some sort of what do you call um, break, right? Some kind of buffer storage has to be there, so that this machine which is taking more time can be fed the part later, okay, one by one from this buffer storage. So that's why you have this uh, called synchronous transfer system, right? Clear, right? So that's your intermittent transfer. And then asynchronous transfer, so also referred to as a power and free system, allows each work part to move to the next station when processing at the current station has been completed. Each part moves independently of other parts, hence some parts are being processed on the line at the same time that others are being transported between the stations. So they move independently, right? That's why you have this name called asynchronous transfer. And while some parts are being processed on the line, right, at the same time some parts are transported between the stations. So this is why you can have this independent type of system, right? Need not to have all of them at the same time. They're independent. offers the opportunity for greater flexibility than do the other two systems. So in process storage of work parts can be incorporated into the asynchronous system with relative ease. So you see, the reason why flexibility is more here, because you can have different processing times, right? So, and is very much a practical case that machines, for some operation it may require 10 seconds, for some other machine it may require, the operation is very simple, okay, the very adjacent machine may require 5 seconds. So what do you do in that case? So in that case, what you have to do is you have to go for this asynchronous transfer of system, where you can have this flexibility of different processing times. In process storage of work parts can be incorporated into the asynchronous system with relative ease. So in process storage, right, as another feature. And power and free systems can also compensate for line balancing problem where there are significant differences in process times between the stations, right? As I told you, in line balancing you have this issue where you're trying to set up a system. When you're trying to design this automated system, you will incorporate these things, that process time, what is the process time, can I integrate this process in here, or should I make a different flow line for this? So these systems, they will try to compensate for those problems, so it will make the designers, the one designing the automated system, and make it convenient for them to design this automated system. Okay, I hope that is clear, right? Methods of work part transport. Yes. So let us see a video regarding this work part transport. Okay. Yes, screen is visible, and please confirm the audio is also, I mean, you can hear the audio also. Yes or no? Yes, students.
Yes, sir.
Okay. Now you understand what we mean by continuous transfer system, right? That it all happens while they're moving. Okay, not static, but while they're moving. Okay, that's the basic concept of continuous transfer system. Okay, and the very best example is your beverage system. And here I don't think that's quite clear in this video. Okay, we'll see. Yeah, this video. You see, they are now being oriented. That's the first step. Okay, proper orientation of bottles through unscrambler machine. You see what is happening with that rod you're seeing. I hope that is clear, right? What is happening with that rod? What is the purpose of it? No one. You see, the bottles were coming in line. Okay, I mean, from that random flow, they were coming in this conveyor system, right? So they were coming, but they were coming like one with one. I mean, the screw. What do you call that? The top part. Okay, was having either it was. How can I put it in words? That they were not in the exact orientation. Okay, the top part may be coming in first here, or the bottom part, right? Two ways to do it, right? Because the space that you're seeing, it only takes in like this when it is in this way, right? Vertical. So either the bottom could be coming in first, or the top part could be coming in first. So but we want it to be of one orientation. So that's what is happening there. If you observe carefully, that spring is trying to take the this opening and try to reverse that orientation. You see, observe. Clear, right? You see, we even saw this in part feeding devices, right? Selector and orienter. Remember, I told you that there could be even another type of mechanism to do that. There are different ways to achieve it: spring blade system, or wiper blade, or it could be even this, right? You see, they were lying down, and this is used to, so that we used to make them vertical, right? Observe. So all these are before they come into that filling line, right? Selector, orienter, and the first one was your part feeding, right? I mean, the starting point of it, that spring what we saw, right? see how that what do you call, uh, there's a specific name of it in your injection molding. uh, Screw, yes, screw is what you call it. So how that is used to separate them, right? So that they don't collide with each other, and the space that you're seeing should be exact for this nozzle to come in, right? So that's another type of orienting it, right? So all these are basically cleaning processes, right, before filling it. Okay, and the filling is after this. Yes, we also have this types of conveyor systems up coming up topic. So you see that bottom one, that's a conveyor, right? Belt conveyor. Now different types of it, roller conveyors you have, and you even have this what do you call, chain conveyors also. We'll see that. Just wanted to you to observe that. Okay, conveyor systems. So this is what category? Continuous or intermittent? Yes, students.
Intermittent.
Yes, because they are not continuously moving, right? They're stopping in between. So that your beverage filling bottle that we saw earlier, this video, this they were continuously moving, right? But here you have this intermittent motion, right?